In this video, we will learn the Python function, how to write a Python function and the Python class. These two are important because a lot of the times we don't want to repeatedly running a chunk of code, so we define them in a function or in a class. This part is inside of the lesson 1 posted lecture slide, or even though here it says lesson 2. But it was the first set of the posted lecture. Is the item 1 and 2 will be in this video. So first is the function. For Python functions, you need to specify a name of the function and the input arguments, and also a bunch of operations inside there, and the return command. Return command is optional. So first thing is this keyword definition. You saw the DEF there. This DEF is necessary in order to be recognized as a function. So that means that it's starting to define the function. And this parameter in this case is the name I gave to this function that I want to calculate the parameter of a rectangle. You use whatever name that you want for your function, but make sure that in the name of the function, you do not use the space or the dot, because the space will be treated as error and the dot is reserved for accessing properties of a variable, and you will learn it when we are going through the class definition. Okay, so here, this is the function. We want to give a name of the function. This is the name is given as parameter in this case. And afterward, you give the variables, input variables. Here are the input variables. I have 2 of them. The first variable is just the width, and the second variable beyond the name height, it also has a value of 1. This 1 is a default value, which means that when I call this function parameter, I could provide 2 values. It will do the calculation using the width and height. If I only call the function with the one value, that one value will be treated as the width, and the height will use the default value of 1. So for this function, inside of that is the body of the function, and you do whatever calculation you needed inside of there. For the function, this command to be inside to do all the operations, they need to be indented. So if you look at the space here, this is the identical amount of space, indicating that all of those belong to this function. So what I did here is a simple print command and a return command. For the print, I wanted to print the string, the width equal, and then the numerical value of the width, and then print another string, height equal, and the value of the height. So as you can imagine, when it prints, it'll give me the width equal a value, height equals a value. And these two are just separated by a space, because I didn't put anything else to separate them. And the return command gives the value of the function when you call it. In this case, it's twice of width plus height. So that's basically the key part of a function. So summary, in the definition of a function, what we need is the def, the keyword, and the return command if you want to return something. And the name of the function follows the def, and the input arguments are inside of parentheses. This semicolon is also important because it indicates that below this, after this semicolon, what you are going to have is the body of the function. So that's this function. For functions, when you try to call them, you simply just use the name of the function and then the value. For example, on the previous slide, we defined the parameter, the function. I can use this command to call it, say parameter, and then I put in the value for the width and the height. The height and the weight, those are the keyword or the arguments that we give when we define the function. So here I directly have the keyword and the value. Because the keyword height and width are used, so it does not really matter you use which one first. On the other hand, if you simply just provide values such as the parameter and you put in the two values, 2 and 1, then the 2 and 1 are treated as those variables in the corresponding position. So 2 is, if we go back to the previous slide, you see the 2 is width and the second one is height. Therefore, width will become 2, height becomes 1 when we run the function. If you have both of the just the value and this keyword plus the value, so the value alone is treated as positional argument value, and the keyword with the value is treated as the keyword argument. When you have both positional and the keyword argument, the keyword argument need to be put in the end. You could have multiple keyword arguments, but all the positional argument values must be fed before the keyword arguments. This is because for the positional ones, they have to be in their specific order. And there's if you skip one, for example, let's say suppose I have a function, and this function I'm going to have 3 values. This function, let's call it ABCD, and that's defined as this contains three of the input, X, the Y, and the Z. And then I define whatever the calculation I want to do. And inside of that, I want to do the X plus Y and times the Z. And this is my value. And then I want to just return this value. And this will return the calculation of X plus Y and then multiplied by Z. So I needed the multiplication sign here. So that's my definition of the function. And then afterward, if I want to call that, I will need to be in a new place, okay? For calling that, I'll do A, B, C, D. And suppose that I want to provide the 2 values. You wanted it to be 2 and 1, and then the Z equals 2. This is fine. It will interpret 2 as the value for X, 1 as the value for Y, and Z is 2. So this is fine. And similarly, if you do A, B, C, and D, you want the X equals 2, and then you put the 1 and 2. This will be an error because X equals 2, this is treated as a keyword argument. But you have 1 and 2, those are positional without any keyword. So this one will be an error. Okay, so this would not work. On the other hand, if you want the 1 to be X, Y to be 2, then you can do it like this, A, B, C, D, and then Y equals 2, X equals 1, and the Z equals, for example, value. Even though my XY position switched, but because the keyword X, Y, and Z are used, so this is okay. This will be fine. Sometimes you may not know how many arguments do you have in your function. So in that case, you could just put a star here, like this example. Here I have the definition for parameter 2 function, parameter 2, and the argument is the star with arcs. Okay, this star basically means that I could have multiple of arguments in there. I just don't know how many in there, so I don't really want to list one by one. So instead, you just do a star of it, and then afterward, this will be treated as if things are separated by comma. And how do you use each one of those arguments? You simply just do the arg0, like arguments here. This is the arguments 0, means the first variable. And arguments 1 is the second variable. So by the way, Python uses the 0 index, 0 as the starting index. Python, behind of the Python is C. C code use 0 as the starting for index. R use Fortran as the code behind, and Fortran uses 1 as the starting index. So make sure you don't mix this part, okay? So 0 is the first one. Once we call the args0, that will be the first variable, and the args1 will be the second variable. And in this case, I'm just giving it to a variable called width, height, and so on. And then afterward, I would have the width and height. So in this case, we use the star with the args there. Okay. You don't have to use ARGS. You can use star by variables, whatever. But later on, it will. If you do star my variables, later on when you call it, it will become my variables square bracket 0 and my variables square bracket 1. Okay. So in my example, I had 2 of them. And you could have more than that. You could use 3 or 4. But the point is that when you try to use it, you need to, what I mean is when you call the function parameter 2, you need to feed the needed number of arguments. Like this example, when I try to, if I want to call that, I have to provide 2 arguments because as you see, I have the 0 here and the 1, so there are 2 of those. Therefore, when I try to call this function, I have to provide 2 of them. This example, say I'm trying to put the square bracket 2 and 3. Even though you see 2 and 3, but they are inside of the square bracket is treated as a single list. The single list contains 2 entries. Unfortunately, because it's a single list, this will not satisfy the need for this function, because this function needs args0 and args1, so it actually needs 2 of those variables. So correct way of calling this function would be you gave 2 input here, the 2 and the 3 separated by comma, not in the square bracket. And once I put in the 2 different entries, it will give me the correct answer. What if I put 3? 3 is fine because as long as you have the 2 that's needed inside of the function, it will be correctly executed. Okay, so this is if you don't know how many arguments are in there. Another one is the one that's given here. This part is very similar to the one with the star args, but without the star. When you don't have a star, then this args, ARGS, is predetermined to be a single input. And that single input, depending on how do you define it when you call the function. For example, here I have args, and inside I also use the args0, args1. But without specifying the star, this args would allow to be of different type. For example, I could put in a list. I could also put in a tuple. After finish the maybe, okay, let me try to share with the computer screen so that you could see if I try to run it, okay. New share. I wanted just a second. Multiple share, okay. A new share, I wanted to share the screen here. And I'll show you the function. Okay, so here, reconnect, okay. And I wanted to have this definition for the parameter. def, and then parameter. And I'm going to have the args here, and then I will have the definition inside of that. Inside, I just want to do the args0 and then the args1. And these two, after add up, I need to multiply by the 2. This is the value that I want to return, 2 times that. Okay, so this is the function. When I try to call this function, I could call it with the def, sorry, not def, with the parameter. And this parameter, I would put in, for example, if I put the square bracket, the 2 and 3, that computed directly the twice of 2 plus 3. So this is the one example. And then the next example, say I don't want to use square bracket. Instead, I'm going to use parentheses. And this tool should give exactly the same result. This parenthesis actually means that we're defining a tuple which contains 2 values, and this tuple is provided to parameters. And here the square bracket is a list, and this one list is provided as the input for this function. Let me run it. And you see both of them give the same result. And what if I just directly try to print with the parameter, and then I'm going to put 2 and 3 without parentheses or the square bracket. This time, because the args here is a single one variable, and now when I'm calling it, I'm providing 2. Guess what will happen? You see that parameters takes 1 positional argument, but I provided 2, so that becomes an error. Okay, and the first 2 print command gives the computed value correctly. So if you do not put the star here, it indicates it's just 1 argument. Now, what if I redefine everything, but I want to use it as a star? Okay, let me copy that part and delete this cell. I don't really need that output. Here, let's put the definition again, but I'm putting the star here. This star tells that what I put is going to be multiple input rather than just 1. So if you have a multiple multiple input argument, this will become a problem because we are looking at the first one and the second one. So even though we have a list, but this is treated as just the one of them, it will not have the second available. So that's going to be a problematic one. Similarly, this could also be an error because only 1 tuple rather than 2 input. But on the other hand, this will become the correct one. But because the 2 of the wrong ones are first, we will see error. And the code behind that will not be executed. You can see here. So error happened for the first print command because it was 1 input, but we needed a 2 inside of the function. You also see this red highlight tells that where the error occurred. Similarly, the second line would have an error, but it's not indicated only because the first error will make the code, the entire compiling stop. So if you want to see the second, let me comment out the first so that you will see how it is for the second. Again, because here it tells that we need a multiple argument and how many multiple, we are using 2 of them. So you feed only 1, it will give the error. Okay, so let me run it. You saw the first was skipped because I put a pound sign. Pound is meaning that that line is a comment. It will be ignored. And this is the one that 1 input is given, a tuple, 1 input. But you're asking for 2 of them inside of the function, therefore the error happened. The index out of bound, out of range. Okay. Now let's see what will happen to the third one that we have provided the 2 and 3 as separate entries. This will give us the correct output. So that's about the star with argument. It means we're going to have a multiple of input arguments to provide. So that's for multiple input argument, just directly as positional. If you wanted to have the keyword, this one would not allow us to do the keyword. If you want to use the keyword, in that case, you need to do double star. Let's see, I'm going to copy this function again, but this time I will use some keyword inside of the function. Okay, so because I want to use keyword, so here I need to use double star. With the double star, and this time I don't really need to do the arc0, arc1. Instead, 0, I will need to put in the quotation mark and the name of the keyword. So what's the name of that? Let's say I want the width, and the other one is the height, also in quotation mark. But when you do so, you are basically telling that this args itself contains the width and the height as a dictionary. A double star inside will, the internal code of this double star will interpret the args as a dictionary that has, you see the help shows up, right? It's a dictionary, and dictionary is always defined as a key and the value. The key is a string, the value is anything. So in this case, the width is a key, height is another key, okay? So that's my definition. And when I want to use it, I'll do the function. And then this time, what I want is, okay, let me change the function name because we've been using that same function called the parameter 2. And for this case, I want to have the width equals 8, the height equals 9, and the area equals whatever, unknown. And you can even have more, but as long as what's needed inside of the function, like here we have the width and the height, what's needed in the function are provided, the rest of them are fine, irrelevant. So let me run this one to see. You see it gets the result of 34. So twice of 8 plus 9, that gives us the 34. So as you see, I'm able to provide the keyword width and the keyword height. That's because I have this double star in the definition for the argument of the function. Okay. So this is if you have this function using the keyword, but you don't know how many of the keyword arguments do you need. So let's continue. We were talking about the function without knowing how many keyword. So we did like this one, this example, double star. Okay. The next one is sometimes you might want to define a function such as when you submit homework and you are trying to do one part of the homework, but the other part requires definition of a function, but you don't have anything ready for that part yet. So in that case, if you don't put that function in there, when you submit the homework, the Gradescope will tell you that it's missing the function that won't run. So you will need an empty function. So empty function itself can be done if you put in a command like a pass here. This is the definition of a function called complicated. And inside, I don't know how many arguments there, but I know that I'm going to write this function later. So at the moment, I'm just going to put a pass. This means that when it runs this function, it will just directly pass this one. But if you only have a definition and without the pass, just a single line definition without anything in it, it will become an error. Okay, so that's the empty function. For function, we can also define the recursions. And recursions is actually one of the reasons that we want to use these computational tools to do that, because repeatedly calling the function itself is much faster in computer than we compute ourselves by human. Here's an example. For this example, consider a person wants to climb upstairs, and at any step, this person could climb 1 step or 2 steps at a time. How many ways can the person climb upstairs? Assume the total number of steps is n. For answering this question, the first thing you want to think is that this person could go 1 step or 2 steps at a time. Imagine at the start of the steps, then this person could be directly going to the first step or the second step, and so on, keep going this way. But if we try to start from 0 all the way up, that's going to be too many to think of different scenarios. Instead, after we thought about the 0 and the 1, let's look at how do we get to the top, the very last one. In order to get to the top step, then this person must be either on the very previous one, or let's say the n-1 step, if what the person wants to get to the nth step, or this person need to be at the n-2. Which basically means that if the person already get to the n-2, that step, then the person could directly skip one, move on to the final step, or the person can be at the previous step n-1 there, and then do 1 step to get to the final. So these are the two things. From the first one, you see the S of n is the number of ways to get to the the last step, and the S n-1 is the number of ways to get to the n-1 step. And the n-2, S n-2 is the number of ways to get to the n-2 step. And then the total would be simply just the previous 2 steps, the number add up together. So that's a recursion relationship. We also know at the beginning, if we start with the 0, we have just if your number of steps n is 0, in that case, there's only one way to do that, directly be there. And if your n is equal to 1, which means that you start from the ground, how to get to 1 step, there's only one way, directly there. So S1 is equal to 1. So with these boundary conditions S0, S1, and also these recursive relationship Sn with the previous tool, we can define the function. So definition is written as this, def, and the name of the function is the capital S here. And argument is the n, and inside of that, I will use the condition. If n is 0, you see the double equal. This double equal is because for logical comparison, you have to use double equal rather than a single equal. Okay, so that's a double. You need to pay attention. If it's n is 0, then directly return the 1 as the solution. And this one, ALEF, means else if. For Python, else if should be written as ELIF rather than the full spelling. Okay, so that's else if. And in the else if, we also put the condition here, and then we return the value of it. And similarly, the next one is if it's not 0, not 1, therefore it is the else part. For the else part, we return the calculation based on the S of the previous two of those computed values. And the S of the n-1 and S of n-2, it will call the same function. We keep going all the way until S0 and S1. Okay, so that's this definition. Go back to think that for the definition of function, you need all these indentation. Okay, so that's one level of indentation. And the next level of the indentation is that when you have this if, else, if, and else, you again need an indentation. Within the if block, everything in there need to be indented with the same space. It doesn't matter that you indent with the 3 spaces or 4 spaces. Default is a good idea to use the same 4, for example. But sometimes if you have too many of the different these kind of nesting, like for example, you have the for loop, you have the while loop, and you also have the if, and inside of if you have other if condition. In that case, too many levels of the nesting, and you have too many of the 4 spaces for indentation, you might end up having the line being too short to write your code. So in that case, you can choose, for example, indent only 2 characters there. In the else if, you also need to have the same amount of indentation, so it is for the else. Okay, so that's the indentation part. Beyond that, the next thing that you want to pay attention is that just like in the definition of a function, you use the colon to indicate is the start of the block. Here, in the if after the condition, we'll also use the colon to indicate is the start of that if block. And so is for the else if part here, and also for the else part. Okay. So that's for the recursion. And in this case, you might have noticed this function actually was computing something similar to the, let's see, Fibonacci numbers, except that the Fibonacci number initial values are different from this one. Okay, so that's this function. And if you call this function with S3, then because you put a 3 here, the 3, it will go through the if condition, and it's not that. And then they went to else if condition. Again, it's not that, and then they go to the else part. And in the else part, it will run S of 2 and S of 1 add up together. Oh, sorry. Yeah, S of 2 and S of 1. And for S of 2, again, it will pass the if, pass the else if, and go to here. It becomes S0, S1. So in the end, S0, S1 give us 2. So S0 is 1, S2, S1 is 1 together, give us S2 is equal to 2. So S2 is 2, and then the S1 is 1, so 1 and 2 together give us 3. If you keep going like S3, S4, and so on, you get these answers. Like S16 is 1,597. You know, 16 is the typical number of steps for a flight of stairs. So if you could either skip one or direct it one step at a time, then there are 1,500, like almost 1,600 number of ways to climb upstairs. Okay, so that's this recursion. The next one here, we're going to define a class. What's a class? Class is the thing that allows to have multiple properties. And these properties could be, for example, a constant or a function doing some computations, or even more complicated stuff. So that's a class. For the class, quite often you hear that the object-oriented programming, this Python and Java, both of them are like that. So-called object-oriented, meaning that we define an object through the class, like this one. This example is my cat. This my cat is a class, and inside of that, I have name and birth year. So basically, if I define an object like this one here, my cat parentheses, that basically initialize a cat. Okay, this cat called C1 is equal to C1. And the C1 will have the 2 properties available. One is given as the name, the other one is the birth year. And to access that property, you simply use the C1 dot name and C1 dot birth year. So that's how you access the property of this initiated object from the class. Okay, so as you see, whatever you define inside of here becomes a property of an object that's defined from this class. This is the initialization of that object. Okay. So in this example, what you saw is a definition that contains two of the constant values for this class. Different from the function is that in function, you use df to start, and in class, you have to use the class as the keyword. Another difference is that in function, you need the parentheses for the input argument. In the class, you do not put the input argument directly by the name. Instead, you only put the function as you only put this class name here. And if you need any argument, we'll talk about it on the next slide. However, if you do put parentheses and inside of that you put something, whatever, for example, let's say, suppose I'm going to put a parenthesis here, and inside of that, I'm putting something else. And what is this something else? Let's say I'm going to call it V, okay? Then this V will be interpreted as another class that has other properties. And this myCat is going to be an extension of the class V beyond inheriting everything that's inside of the V. So basically, you are extending the class of V and you call it myCat. And whatever that's available for V and the object initiated for myCat would also have those properties. At the moment, you don't need this yet. So just do not use parentheses. Instead, just directly the name of the class with a colon to start the definition. And for constant, you can directly put right underneath here, like given the name, birth year, and so on. So that's the most, the simplest definition of class. But for this definition, we only have constant values, like name is always Buqi. Now you want a different cat name. For example, you have two cats, one is Buqi, the other one is Alex, then this function would be insufficient, right? So we would want a class definition that allows to use different names for the cat. Here, I would like to pass the argument to the class. How do I do that? You can use this function, built-in function called init. Init here basically is like initialize this function, okay? The init, before the init, you have a double underscore, and after the init, it's another double underscore. And in the parentheses, you will put the argument. Here I have the name, and I also have the birth year as the argument. Beyond these two arguments, I also have an additional thing called self. This, whatever you call it, here is called self. Self is referred as the object initiated for this class. For example, if I say C1 equals myCat, okay, C1 equals myCat. In that case, I basically say that this self is this referring to the C1, okay? But when I call C1 equals myCat now, this time, because I have the name and the birth year, I will need to provide the two values here. The two values, for example, for the name, I can put Alex, and the year 12, for example. Sorry, the birth year 2008, for example. Okay, so that's an example of this. This C1 is an instance or an object initiated from myCat. And this myCat has two arguments, Alex and 2008. And these two are provided to the name and birth year. And the self just refers to the C1 itself, okay? And then inside of this init, you put those default operations that you want this object, the whole class to execute. For this case, I just put the name. I do self.name equals the name. I put the self.birthday equals the birth year. So if I call this function like this C1, I would be able to have the C1.name and C1.birth year. Okay, so let me try to do that. Let me go back to our Colab example, Colab here. We'll define the class, okay? So this class here, I will have it call it my cat and a colon. Afterward, I will start to have the function for init. You can also define some other things. But before, okay, if you want to define other things, for example, I wanted to add additional property to my cat. What's this property? Whether my cat has vaccinated with vaccine equals yes or no. Okay, vaccine, okay, that equals yes. Okay, so that's a string. And when I define my function here, underscore, so double click this underscore and another time double underscore and init, okay. And you return, it will start to give you this block. And the first one has to be the self, and the next one, let's give the, we say that we want the name and the birth year, right? Birth year. Okay, birth year. So inside of that, I don't want to pass, I need to do something. And inside of that, I want to give the name. So basically, if any of this object of my cat is initiated, I want to give the name from input argument name. So self.name, this is the variable called a capital name, capital N, okay. And that's equal to the input is the name. And I also want to give the cat's birth year, use that, and then the birth, I'm going to call it birthday, and that's equal to this input variable birth year. Okay, so if I finish running this one, what will happen is if you initialize my object from this class, my cat, then this my cat will have 3 properties. One property is called vaccine. The other property is called name, and next property is the birthday. So let's try. Suppose I wanted the C1 equals my cat. This is the initialization of this object, and I have to provide the input argument because init is defining the tool input argument. So first one is name, Alex, and the second one is the year, birth year. Let me do the 2008. So if I run that, I want to see what is the C1 and what's the property of C1. I'll do C1 dot name. Let me do the print, okay. And I also wanted the print of the C1. And let me also print the C1's vaccine. And print the C1's birthday. Oops. C1's birthday. Okay, so you saw that I have the C1, that's this entire object, but in this case, it's going to be telling you that it is a function object. It's not giving you the value yet. But this one, I'm sorry, the C1 will tell you it's a function object. It's an object. And this one will give you the name as the Alex here. And this one will give you yes, because it's calling this vaccine defined, okay? And the next one is this birthday, which was given by here, which will take the 2008. So let me run it. oops, error. My cat has no vaccine 1. Oh, okay, that's because that when I define it, the variable was defined as vaccine, but when I called it, I accidentally had a 1 there. So I need to delete that 1 and rerun it. So now you see, this is the first one. When you print the C1, that tells you that this is an object, my cat object. And if you want the properties in it, in this case, I'm showing actual values like Alex, yes, and so on. If I want to know what properties are available, let me try with dir of C1. With this one, let's see, you do the dir, it shows you what properties are available for this C1 cat. So this cat, you see some of those that start with this underscore, those are all the default that comes with all the, except for this init. The init is the one that we specified what we want to do in it, okay? Other than that, these are the constant defined in it. If you have a function, it will also show up here. So birthday and the vaccine, and there should be name too. Let me see, where's the name? Oh, name was given here, okay. So that's the seeing what properties are available. You use this dir to see that. So, okay, this example, we explained what is how to define a class. So that's the keyword to define a class. And this is the name of the class. And here is the constant defined. And this is the operation inside of the init gives a definition of what operation do you want, and also provide pass the arguments like these to this class. Okay, so earlier I mentioned that if you put a parenthesis, then you are actually extending that class. Let me try to remove this one. I don't want this one anymore. Oops, that's, sorry, I want to remove this one. So let me define another class, and this class, I will extend my cat. So what do I want to define a new class? Class, and this time, call it cat2, okay, a new class. And this class, that's extend my cat. And then afterward, let's do this. And inside of this extended cat2 class, what do we want is we want to put a gender. So in here, let's put a definition of this init. And inside of here, what we want is let's say the gender or the sex, a gender. Okay, let's put the gender there. And what do we put for the gender here? We're going to put, you see there's this super. Super basically means that it will be given to the previous one. Not only given to the previous one, instead it's a add-on to the previous init function. And for the add-on, oh, just now I was putting in the, sorry, before I put the gender, let me go back to how it was. So this was the original one. And beyond that, this was the init that was in the original one. And I do a super here, it will try to add additional stuff. Let's suppose, say here, I want to have the gender in it. And what do I want to do is I want to, this part will try to call whatever that's in the my cat. And then afterward, we'll try to do more things. So self dot gender, make it equal to, like, for example, gender. So that will give the gender definition. And so that's the definition, extending my cat. Let's suppose we're going to have a C2 cat, okay? C2 is equal to cat2. And let's put in the name is Buqi. And the birth year And then I want to put gender male, and let me run it. I want to see the C2 dot name. You see, I put a lower name. That means that it suggests this one. That means my lower name does not exist. Yes, back then I defined as capital name. And I want to print this one. And the next thing I want is the print of the C2 dot. Let's say you can do the birthday be like whatever birthday is that. If you don't know when you do the dot, it already had all the suggestion of what's available. The birthday available, the gender is available, and the vaccine is available. Let me put this gender here. Okay, let me run that to see what I get. So as you see, this part basically is abbreviation of including everything in the previously defined MyCat class. So that's because here I had MyCat, and this super command will basically put everything that's inside of this one being executed and carried over to here. And in addition, other things were added. This is the other thing that I was adding to it. I'm adding the gender property to this class. So in the end, when I initialize this cat2 object, it will have all those that's in MyCat through this super here. And in addition, it also has these additional ones defined in this function. Okay, so that's about the class. Okay. For all of the homework submission of in the Gradescope, you will have to define class to do the submission. Okay, so that's about the class, and this is self argument. What a little bit more about that. We already saw that self in the init. Beyond that, when you define any other function, for example, area, let's suppose we give the radius r, and we want to compute the area and the parameter of the circle. The def area calculates the area. So first argument again needs to be self, and second argument is this radius. And inside of that, we do the calculation. In this calculation, I use the pi times r squared. The pi, that constant, is inside of the NumPy package, so I have to do import NumPy as np and then np.pi times r squared. So that's the definition for this area. And this self has to show up there because that indicate if I initialize an object of circle, the circle will have this area as one attribute. If you do not put a self here, then this function will not be available to the initialized circle. Okay. So that's one function, and you can define as many functions as you need for this object. So next one is a parameter. Again, I have a self and the r. And computation is 2 times n pi times r. So I have two functions defined, and each function you always need to start with the self, and in addition, you put in whatever other arguments that you need. Okay. So here, if I initialize circle 3, that means that I'm initializing an object with 3 as the radius. And why do we put a single r equals 3? That's because of here in the init, r is the single input argument beyond the self. Okay, simply look at circle 3. What you get is telling you that this is an object, circle object. Okay, and this is the address of where that object is located. And then you want to see the property of it, you can use dir with the C in parentheses, or otherwise you can put a C3 equals the circle 3, and then you see dot D, this is the dot D part, and the dot A is the area part. D is for the diameter, twice of the R, and then the dot P is for the parameter. Okay, so that's for the class with all these self argument is needed in all the functions defined in a class in order for this function to be accessible for the defined object of this class. Okay. This self, the keyword self doesn't have to be self. You could use other name. For example, if I don't call it self, I can call it obj. If I call it obj, then everywhere I'll have to refer it as obj. And later on, when you call it, it's going to be the same. So whatever you put in as the first argument in that function, that becomes this object itself. Okay, so that's about the definition of function and the class. So summary, for Python function, you use the def and then function name, and then you put arguments in parentheses. All the computations inside of the function need to be indented. For a class, you use the class and then class name, and then you use the indentation again. And inside of the class, you define constant or these functions. This init is a built-in function that if you use it, it means that these are the functions, these are the operations that will always be done whenever this object circle is initialized. Okay, use this init to do things that you have to make it to run automatically whenever you initialize an object of that class. The self is always needed in all these functions. And if you define constant outside of these functions can directly do name of the constant equals value. But if you want the constant to be accessible and this constant is computed somewhere in the middle of the function, and you want that constant to be accessible after object has been initialized, you can use the self dot with a new name of the constant, then that could be accessed. This constant could be in any of these functions, doesn't have to be in just the init. For example, if my self dot capital D is inside of this area function, I could also write self that little d equals twice of r, and that will also have the little d object property available. Okay, so that's the class and the function in Python.